Hello everyone. Hi. Welcome to the Hive. My name is Mikhail Brandon. I'm an attorney here at Perkins Coie. I just want to tell you a little bit about where you are since we have you all here together. We're a law firm, we're an international law firm at that. We have over 1,000 attorneys. We're in 19 different offices. We're in Shanghai, we're in Taipei, we're in New York, Seattle, we're in San Francisco, and we have an office here in Palo Alto. There's about 50 attorneys here. Our focus is technology companies and startups, and it's divided pretty evenly between doing business work for startups, getting them funded and getting their options out, and also doing IP work. So some of the companies that we do work for are Uber, Square, Facebook, Google, Intel, Amazon, Microsoft, Phil's Coffee, I'm really excited about, Box, Cloudera, Magic Leap, Secret, the list goes on. Instacart, we just got. And we take companies from all stages of growth. So just a couple people with an idea, all the way as they're growing and hiring on employees. And if they get big enough, we help sell them or take them public. We also represent investors in the startup business practice. So we represent venture firms, angel investors, and other kinds of friends and family and wherever you need it. So all I want to say is if you have a business idea, if you're an investor, if you're looking at an investment, you're in the right place. Please come and talk to a Perkins attorney. And with that, I hope you all enjoy the Hive today. Cheers.
Hi everyone, thank you for being here. To make it very short, we have an amazing panel of speakers tonight and a very exciting and timely topic. So my name is Pashu Christensen, I'm with the Hive, and I'll just say a few words about the Hive think tank. You are part of the largest big data community in the US and maybe even in the world. We have over 6,000 members. It's a community of data scientists, developers, engineers, artists, designers, all focused on big data. We host events every week, every Wednesday evening. Those are some of our upcoming events. We have even more coming up later on. So as you are a member of the meetup group, you can check out all of our events and register. We'd like to thank our sponsors and who is here from Aerospike tonight. I've seen a few red shirts. And MAPA, I know there are a few people from MAPA as well. Thanks for being here. Anyone from HP, Cloudera? No? So yeah, we'd like to thank our sponsors and partners. And Aerospike is here tonight. I know Jen wants to say a few words about the drone that someone here is going to take back home. So.
Hi everybody. As you know, Aerospike is sponsoring the giveaway of a drone tonight. So one of you lucky audience members will get to win it. So I'm going to leave this fishbowl on the other side of the room. You have until the end of the session today to put your card in, and at the end we're going to be doing a live drawing. You do have to be present to win, and Sukant will go ahead and pull a winner at the end today. So good luck everybody.
Thank you. Thanks. And with this, please make sure to continue the conversation online. There is a wireless with a guest Wi-Fi, Nebraska. So we have a hashtag tonight, Hive Data. So ask questions, post comments, pictures. Let's continue this very interesting conversation online. And with this, I'll give the microphone to TM Ravi. He's the founder of the Hive. Thank you.
Thank you, Pashu. So this is going to be an exciting panel, and so I'm looking forward to it. And thank you, Nick, for hosting this panel discussion. So just briefly about the Hive. The Hive is an early stage fund. We incubate, fund, launch companies. They're all companies that are building applications focused on use cases that leverage data. One of our companies, a number of you came up and talked to me, and one of our companies got bought 2 weeks back. How many of you know Lance Riddell, who was the CTO at the Hive? So So he was the founder of this company along with a fellow called Jure Leskovec, who's a faculty member at Stanford. So they are now employees of Pinterest. You'll see that we don't do any infrastructure. So unlike a number of the gentlemen here, we have focused more on applications and use cases across a number of different segments. And one of our latest companies is a company called Foghorn. And this company is just on a tear and hiring more and more people. So if any of these positions are a fit, we'd love to hear from you. So be a part of the conversation, as Pashu mentioned. So use the hashtag so we can all see what you're saying. And with that, I'd like to hand it over to Nick.
So for those of you who don't know me, my name is Nick Hudecker. I'm an analyst at Gartner on the information management team. So I talk a lot about DBMS, data warehousing, Hadoop, as well as NoSQL. So I'm very happy to be here tonight moderating this panel with a great group of folks. So with that, I'll turn it over to Paul to give a quick intro and a few seconds about Mongo for those of us who don't know what that is.
How long could it be?
A minute, 9 seconds. It's a good question.
My name is Paul Peterson. I'm the Deputy CTO of MongoDB. I work down here in Palo Alto. Just on the off chance that you don't know anything about MongoDB, it's a non-relational database. It has emerged as the market leader. I think principally because it's general purpose. I mean, it's and economic. It's extremely cheap and extremely flexible.
You can hold it closer.
Closer.
Is it not on?
Close.
No, it's on, you just have to hold it closer to your
All right.
Yep,
Is that
much
okay?
better.
All right. Should I start at the beginning? Rewind? I was saying MongoDB has emerged as a market leader because it's a general purpose product. Think Intel. It can be used for a very broad variety of applications, and we see this because we have more than 2,000 customers. We have had about 10 million, not necessarily unique downloads. It's a product that can be used for practically anything you can think of. Is that enough?
It's great.
All right.
Hi everyone, I'm Gaurav Gupta. I'm VP of Product Management at Elasticsearch. So a little bit about Elasticsearch. We were founded in 2012, but the product, Elasticsearch, the open source project, has been around since 2010. We're about 130 people, raised about 100 million in financing. The company Elasticsearch actually is really 3 different open source projects. The first is Elasticsearch, which was the first one, and that is kind of a distributed search and analytics product based on another open source project called Lucene, if you're familiar with that. Elasticsearch, the product, actually does a lot of things. The first use case it was really designed for was being a backend for search on the web, so for embedded application search. So, for example, if you use Yelp's mobile app while you're searching for things and filtering, you're probably hitting Elasticsearch. Or if you use Wikipedia, you're hitting Elasticsearch when you make your queries. Or if you use Tinder, you're also using Elasticsearch. So that's one example. The product can also be used for other use cases. If you combine it with our 2 other projects, Logstash, which is a data ingestion and parsing product, put data in Elasticsearch, and then you can visualize it with our other project called Kibana. You kind of get an end-to-end ad hoc search and analytics solution that's commonly used for things like log data or security and operational data. So that's another use case for the product. And finally, we're oftentimes used as a document store to do analytics. So it's a pretty versatile product, and looking forward to chatting about it.
Hi, can you guys hear me?
Yeah.
Yeah, my name is Sukant Ganguly. I work for a company called Aerospike. I'm the VP of Solutions Architecture. Aerospike is about 5 years old, based in headquartered in Mountain View, California. We have a development office in Bangalore, India. About 70-ish people, I think 72 now, hiring aggressively, so please reach out. Aerospike started as an in-memory NoSQL database engine. Over the last 5 years, we have established ourselves quite well in the ad tech space. We have started extending our vertical presence, going into financial tech, and then some aspects of telco or telecom. Fast reads, fast writes, NoSQL engine. We look at the database market and address the problem from a system point of view rather than just a database and a query optimization. You would see Aerospike people talk about really, really low latency applications and apps which would expect IOs in milliseconds, single-digit milliseconds. So that's what Aerospike is all about. I'm excited to be a part of the business which is growing in leaps and bounds, and great accolades with customers who have been using Aerospike. Thank you.
Hi everyone, I'm with Oracle, and my name is Robert Green. I'm a product manager strategist for the Oracle NoSQL database. And so how many of you have heard of Oracle? Okay. So apparently our corporate branding is doing pretty good, even though we don't necessarily have great product marketing. So Oracle has a NoSQL database, been on the market now since in production in 2011. Oracle as a company basically recognizes that there's an emerging class of workloads that need different technologies to support those workloads, and the challenge is how is it that you bring those various technologies to market and yet don't end up back in the old days of data silos, and so figure out how to make those things work together. And so Oracle's NoSQL database, which is a key value store, is much more akin to a Cassandra or a React or something of that nature, is a pure sort of NoSQL database technology the way you might think about it, but is emerging with SQL capabilities, just like we see a number of other NoSQL technologies doing. And Oracle is uniquely positioned to take that SQL capability and overlay that in order to provide higher order value across all of these different technologies, while still letting them support the workloads that they're really, really good at it. And so that's what I'm here to talk with you about today.
I have my mic, hopefully people can hear. So my name is Tomer Shiran. I'm VP of Product Management at MapR, and also one of the folks that founded started the Apache Drill project. And so MapR, if you haven't heard, I assume most of the people here have, is one of the leading Hadoop distributions, and our focus really is on making Hadoop both enterprise grade, so things like business continuity, snapshots, high availability, as well as making Hadoop more real time, so the ability to ingest data in real time, analyze it in real time, so as opposed to batch uploads and analyzing yesterday's data, and also the ability to run operational applications directly on Hadoop as opposed to a database on the side. The Apache Drill project specifically, we looked at how do we build the SQL engine for the next decade, as opposed to taking yesterday's technology and kind of making it run on Hadoop. And really we built a self-service data exploration system with Apache Drill that lets you run SQL queries on all the data in these non-relational data stores. Because if you think of what's happening today, a lot of the data today is landing in non-relational data stores. As much as Oracle's not happy about that.
All right, so it's going to be that kind of night. So I wanted to actually have Paul set the stage for us a little bit here, so we can pass the mic down to him. I look at the document stores and the alternative databases that are out there, database management systems, and I kind of have a feeling we've seen this before. Right? We had hierarchical models on mainframes. They got replaced by relational data models, and now we're kind of going back to hierarchical models again. So why is this different, and how is this different from the $0 billion XML database space? So maybe you could set the stage for us a little bit, and anybody else can jump in who wants to.
That's a nice question. I don't know if you realize I'm a co-founder of MarkLogic, which is an XML database company.
I didn't. I just got on.
So it's not quite 0 billion, but it is a niche, no question about it. So I can speak at length on the subject of the difference between MongoDB, for example, and MarkLogic. And the answer there is that the current generation of document databases, of which MongoDB is an instance, are all based on a better standard. JSON, it's just a superior standard. It's simpler, cleaner, it has no path towards revisions or obsolescence, whereas XML is messy, too complicated, committee, too big, too many meetings. It's a horror show, right? I mean, XML with XSLT, with XPath, with XML schema, modular or not, is it compatible with DTDs, and which generation of DTD? This just looks like money down the drain from an IT manager's point of view. The difference between the current non-relational document databases and the object relational databases is that they were also too complicated. In general, I think a good principle to keep in mind is that if there are too many moving parts, it's a bad thing, right? It's just more ways it can fail, more complexities. The maintenance and programming of such systems becomes expensive. So the object relational database attempts to capture the whole object hierarchy of an OO design system or runtime like Java or other, and nobody really needs that. I mean, what you want is a simple object model that's relatively flat. Yes, it's hierarchical in the sense that you have nested documents, but it's not hierarchical in the sense of a hierarchical database. I mean, it's a recursive data structure that's sufficiently expressive that it's extremely easy to create an object document mapping and then to store the whole document and retrieve the whole document, and to keep the objects that you really process in one place, which is, after all, pretty much all that anybody wanted, including the people, I suppose, that use Oracle. I mean, if I'm running an Oracle database or a Postgres or DB2, I have got a manifest, or I've got a profile, or I've got a customer, or I've got some sort of object, business object that I want to manipulate. So who said I should take that apart and normalize it into whatever normal form they said? They told me to do that. I didn't ask for that. I want to process these business objects, and I want to just keep them as they appear, shove them into the database, bring them back out, do the processing, and then push it to the UI. I mean, it's a kind of one-to-one-to-one.
So this is primarily a developer argument, right? Developers want to get things done. Either they're looking to avoid talking to DBAs, and I can sympathize, or they're just kind of tired of the relational model. Are there any other thoughts about how we got here and why?
So yes, that's correct analysis. So it's great enabler. The developers love it because they can get to a result fast, which means increased productivity. Same budget, more projects finished on time, right? Because you just let the developers run with it.
I think there's some truth to that. I would say that to answer the question, which is how did we get here, I think it had a lot to do with the fact that we went through this period of time where we tried to extract the database further and further, the relational database further and further from the underpinnings and all the relational algebra, and moved it up the stack, in the Java programming world in particular. And so we created like a generation, nearly a generation of developers who didn't really think about SQL so much. And I mean, there were at some level, there were the people that still building the really hard applications that still had to think about it. And so, if you think back to the Hibernate days, Hibernate did eventually introduce the ability to put SQL directly into its object relational mapping layers. So, if you really had to get down to it and deal with the performance issues, scale issues that maybe weren't just automatically expressed in those abstractions, you could do it. But in general, you had a whole bunch of people that never had to think about it. And then what followed them was another generation of people. And then they looked to their elders, to their older brothers, and said, hey, what should I do? And what should I use? And it's like, you're in school, it's a university project. Don't bother yourself with all that detail. Grab one of these simple libraries. And so that became the pattern, this componentization pattern. And then the emergence of GitHub and open source and all these libraries, it just became a big shift in how people approach the development life cycle to be able to go out and reuse these components and then build on top of that in order to get more productivity. And I think that lent itself to a set of technologies that were just new. They weren't necessarily better, but they were new, and they brought a few things to the table, like ease of use. I could go on and on about some of the other benefits of NoSQL as a
Well,
product
let's
manager.
actually jump, so let's make a transition from that, from the components and the reuse and the ease of use into what are people doing with this kind of stuff? I mean, what kinds of use cases are we seeing? I mean, I don't see a lot of people, if any, interested in building ERP systems on a NoSQL database, for instance. I'm sure somebody's trying it, but I haven't talked to that person yet. So maybe we can go down the line and talk about one or two interesting use cases that we're experiencing.
Yes, so I think I have a little bit of a contrarian view here. There are applications even now, and there will be applications tomorrow and next year which need the relational view. The flexibility doesn't really gain much in those kind of app environments. But at the same time, the different types of use cases that has sort of come up in the last 5, 6, 7 years, where what we have seen is the type of data that these applications are ingesting into the platform is not well defined. It's difficult to expect the same model of data to come in. So the applications, as they scale out and they're gathering data, they need the flexibility. So from my experience and what we have seen in the field with some of our customers and people that we talk to, there are needs for relational applications which will exist and will continue to exist. And there are new categories of applications that are coming up which expects really fast access, a lot of flexibility, but at the same time, let the app decide what the relation is rather than the model decide what the relationship is. So that level of flexibility has risen just because we have seen so much of growth in the internet itself, data coming from different sources, well-defined websites to sensors to feeds coming from various sources that you would want to assemble, and it makes life easy for a developer to build an infrastructure and actually manage infrastructure where the application is defined, and then you don't have to worry about remodeling your data models 6 months down the road when an app decides to have a different type of a use case or a user flow. So I think it's important to kind of look at those. Those are the things that we have seen in the field. So we generally don't go and try to convince somebody to move from a relational to a non-relational. They do come to us showing us their use cases where there is less relationship benefits within the application rather than the data model.
So you're seeing more greenfield application development than replacement. Okay.
Exactly.
That aligns with what I hear from my
Yes.
clients as well.
Yes.
But Gaurav, maybe you can talk a little bit about the kinds of use cases you're seeing, because if anybody on this panel is dealing with truly no schema environments, it's got to be the search engine folks.
Sure. Yeah, I mean, we're a little bit different from some of the other technologies on the panel. Our focus is, I think one of the things about Elasticsearch is that it was really designed as a search engine first, and it also happens to be a document store. And one of the premises of that is that we really focus on use cases that involve the kind of workloads where you need to do extremely scalable, fast search. So we give up certain things as part of the kind of database that we are, right? Like all of these databases give up certain make certain trade-offs. So the use cases, for example, we see are things like travel booking sites, right? They've been around for a really long time, but there are a lot of those. To be the best travel booking site these days, you need to be highly personalized. You need to be able to be extremely responsive, provide personalized results based on what you might have looked at before, what you're probably going to look at in the future. Take in many different data sources, some of which may be unstructured data like Twitter messages, some of which may be structured data like GeoIP data, and be able to return queries extremely quickly, right? And so, we're seeing the growth of things like Elasticsearch, but also I think generally NoSQL databases is in these kinds of workloads, right? Where you have this high query concurrency and the sub-second response times are necessary. You're not running long jobs. And that search, which for most solutions is sort of an afterthought, is actually the primary action that someone's doing on that particular application. So I don't know if that helps.
No, that does. So the follow-up question is, we've talked a lot about different capabilities, different types of use cases. Developers are completely spoiled for choice right now. And how do they pick, right? We've got an in-memory key value store. We've got a multi-model database in Oracle's product. We've got MapR with a variety of options. MongoDB with a, I'm going to say, read-centric use case addressing, although that's changing now with WireTiger. How do developers make these assessments, and what happens if they choose poorly? So Tomer, maybe you can jump in first on that one.
Yeah, I think each of these data stores has its own kind of sweet spots, right? So if you were doing a big kind of a big data application, you'd want to choose something that can scale to maybe 100 or hundreds of servers, right? And so not all of these technologies that probably Hadoop is kind of unique in that it's one of its sweet spots, right? And so I think it kind of depends on that use case. Another example is if you're doing more analytics, right? So it's not just a simple application like a product catalog that I'm showing things on my website or a simple mobile app, but I'm also doing analysis on that data, and I want to take the data from the live application and run it through a recommendation engine, right? So, for example, with Hadoop or MapR, you can run your live operational application and then run a recommendation, use the recommendation technologies that are in the platform and build some models based on that data in real time on that system without having to move the data to a separate system outside. And so I think you have to look at each of these systems and really look at what is it designed for and what is its sweet spot.
Okay. Can we pass the mic down to Paul? Actually, I'd love to get your thoughts on this as well, because if there's any kind of knee-jerk NoSQL database right now that people are gravitating towards, it's MongoDB. And I think sometimes they paint themselves into a corner because of that. So how do you advise developers?
Okay.
Right? What kind of use cases are you targeting?
Okay, so we have very many use cases. So let me take a moment and basically my marketing people will kind of give you a script. And it includes,
That's not fair.
It is. I wish that I could know the PowerPoint like this. I think it's best to give examples. I mean, a database like MongoDB can be used for practically anything. The case that we tend to avoid is the multi-document complex transaction, shorthand, debit A, credit B, from my checking to your checking or vice versa. And because Mongo just is not optimized for that. I mean, we would steer you to Oracle for that purpose. But I mean, if you're looking at examples like mobile apps, Weather Channel has a mobile app running off MongoDB. You look at a website like Carfax or Edmunds that has a vehicle history database, runs on Mongo. We have companies that do real-time analytics that are running on Mongo. We've got Parse, which is now a component of Facebook, running a multi-tenant hosting solution that's running on MongoDB. I mean, there are tons of examples. What I would say is if a developer is trying to decide which database product to use, they should step back a second and comprehend what a database is. So let me generalize. A database, by definition, is a piece of technology which stores data, and it stores it safely. So you're not afraid that it's going to get lost because this is data that actually matters. You need to have it. It's like safe where you can put things that are valuable and then get them out when you need them. So it has to have both sides of that equation. It has to be someplace you can readily put large volumes of data safely, and it has to be very convenient to extract the portion that you want. So it has to have the aspect of a filing cabinet with a lock, right? So you open it, you can find the thing you want, pull it out, and there it is. Now, the databases are going to be distinguished by the characteristics of how easy it is, at what volume you can put stuff in, and the modes by which you extract it. I.e., what is the query system? What is the underlying storage engine optimized? What kind of questions is it optimized to answer? Now, a storage engine is the component which basically represents the last layer between the optimized query and the actual persistent version of the data that you're storing. Right? So if it's a search engine, your query is just some sort of a phrase, possibly with booleans, parentheses, quotes, not. And it gets turned into some low-level request for posting lists. Right? So the storage engine is basically an engine that's storing posting lists and knows how to do quick and for posting lists. And if that's really what you need, then you should be looking at a search engine. Other databases might have storage engines, one or more storage engines that are optimized for B-tree access, which means point update, range query, possibly forward, backwards iterations across ordered sets. Right? You could have a request, you might have queries that really demand some kind of adjacency behavior. I mean, a company like Facebook needs to know who likes the stuff that I like, who likes the stuff that that my friends like, and who likes the stuff that the friends of my friends like. Right? I mean, there are these linkages.
So effectively, you're really moving the onus of understanding the DBMS from the DBMS to the developer. Right? The developer has to now be far more intimate with how the data is going to be used, what kinds of queries are going to be executed, what the read-write patterns might be. With some of the alternative databases that we're talking about up here than they would be if they were using a relational store.
I get the question, but I don't think I agree, right? Because Oracle or a typical relational database is going to make an offer, which is that you can do a general purpose query and they will optimize it and make anything work. And I mean, experience shows otherwise. The engine sort of chunks away in the background, and it's obviously good for some things and not other things. If you have to do a complex kind of bucketing query, which is going to do a matrix group by, then sort, and essentially the optimizer, the best it can do is some sort of, on the one side of the join, some gigantic scan, and then join, and then, I mean, it's just not going to run that way.
Okay, so you disagree. I think Robert would like to offer a counterpoint.
Well, no, I would just like to know, see, you found out what the weakness is in Oracle's database, but what's the weakness in your own database? You should know that first.
That's for you.
So I would answer the original question, which, we have to deal with this all the time. Oracle has its relational database, and we have its NoSQL database. And so we deal with it from a workload perspective. It really comes down to the kind of analytic, generally. If it's a very simple, easily normalized hierarchical data structure where you don't need complex queries, that the majority of the operations going on are simple key or hierarchical key-based lookups, right? And you need to ingest a lot of that data, and you need to read it out in low milliseconds. Then the NoSQL database is the best database. And if you could you want to do range queries and things like that, yeah, we can do those things. If you want to add a secondary index and do a moderately interesting where clause, yeah, you can do those things too, but they shouldn't be the primary use cases. If you're starting to do things which are much more analytic in nature, require much more interesting join operations, maybe windowing of times, all kinds of interesting query possibilities that happen in the relational world, then you look to the relational technology. And it scales plenty well to take care of that stuff into these very, very large data store sizes that the vast majority of people don't ever have to deal with as well anyway, so that the scale thing is not really a problem. Cost is an issue, but usually if you're dealing with the problem at that scale, then you need to solve the problem, because there's usually money on the table, and so it's more important for you to solve the problem than it is for you to to take an extra year and a half in 100-man resources to figure out some way to engineer yourself around it. Now, back in the early days of NoSQL, some of these problems weren't well understood, and a couple companies have done that. But then later on, you've seen them spin out their technologies, push them out into open source, retrench, move back to other technologies they understand better. And so there's no clear-cut answers here. But look at your requirements, figure out which workload the different technologies satisfy those requirements best, go with that technology. And then don't forget the fact that you've got higher level functions that the organization wants of the data that's being generated from a specific application. And so you need to think about another holistic view later on about how all this stuff is going to live and operate together.
Well, let's talk about that holistic view for a minute, okay? Because if I put a lot of data into a schema on read store, and this question is open for anybody. If I put a lot of data into a schema on read store and I find something interesting, eventually I'm going to want to save the map to that data and maybe move it into something that's optimal for that use case. So are these persistent technologies? Do these things survive, or does your own success eventually make you irrelevant?
So this kind of dovetails into the previous part of the question, the earlier question that you asked about the developers and how much of the onus is on the developer rather than the technology itself. What we have seen, what the industry has actually shown us, and we learn on a daily basis, all of us, is that the applications are, the developers understand their application much better than what we think they do. So when those kind of aspects are actually put into proper context, what ends up happening is, as infrastructure providers like us, we should be respecting that to drive what actually is contributed from as an output of the database technology or any persistent technology. So if it is a matter of the application expecting to have a free-form model and then doing some query, doing some analysis, and then storing a relationship with some sort of a metadata stuck to it, the platform should offer that. And if the platform does offer that, then you have a willing piece of technology that people will accept and adopt. And at the same time, what we have seen is good companies build simple technology. Simple to develop, easy to understand, and easy to use technology. If we keep that in mind, instead of worrying about building, nth level of optimization on a query, whether we do it or Joseph Brown does it, doesn't really matter. Less and less of those kind of applications are demanded in the industry today. The understanding of data and siloing the data which is relevant for a domain is more important, and if you see some of the successful companies out there, that's exactly the kind of businesses these guys are building. So when you build a persistent storage technology, whether it's a database, a flexible search engine with persistent, doesn't matter what it is. If you offer that level of choice to the developer would cherish that, the developer would come up with newer use cases, and you would see more mileage of that product in the industry.
Okay, so you're talking about building intentional silos.
From an application point of view.
From an application point of view.
Yes.
And I think that's directly counter to what MapR's message might be or Mongo's message might be. So I don't know if you guys want to offer a counterpoint here.
Yeah, I think first of all, the world wants to move away from data.